My name is Jan Stücke, and I would say we get started. So today with me is Chris Woodward. He will introduce himself in just a bit. So my name is Jan Stücke. I'm the head of communications at ArangoDB. Some of you might know me from the Slack community or from our Slack channel. I'm doing a bit of community support there. I'm doing a lot of learning content together with Chris and others on the team. And of course, as a communications guy, I'm also doing some marketing stuff. And I'm really excited to introduce you today to a few fundamental topics and features of ArangoDB. But before we dive in, Chris, would you like to introduce yourself quickly?
Oh, looks like it's not letting me show my video, but hello, everyone. As he said, my name is Chris Woodward. I am the developer relations engineer here at ArangoDB. And I'm kind of also involved heavily in creating more learning material for everyone. We've also recently started ramping up some more courses. We are actually going to have a full fundamentals Udemy course that becomes available soon. But I'm also heavily involved in trying to figure out basically what the community needs and doing everything I can to help making learning ArangoDB more engaging and easier.
Perfect. You should also now be able to share your video.
Oh, there we go.
There you are. Hi. Wonderful. All right. Before we dive into the topic, just some housekeeping. You have down below in your Zoom window, you should have a Q&A function and also a chat function. If you have any questions about the stuff we will talk about, feel free to put your questions in there. It's for us super easy to keep track, and you will also be notified if we then answer them live or then later on in writing. There will be also some time for Q&A at the end of the webinar. There will hopefully be plenty of time. So I would say, let's not waste any more time, Jan. Let's get started. All right. So what we will cover today is a general introduction to the native multi-model approach, the idea that we're pursuing here at ArangoDB. We will provide a brief overview over features and use cases of ArangoDB and native multi-model. How scaling works in ArangoDB, a little sneak peek of the managed service, which is called ArangoDB Oasis. We're pretty close to enter the first test phase. And then we will also have some hands-on, and I think this is the most interesting part, where we will show aggregations with ArangoDB, joins, graph, and geospatial queries with our query language AQL. And as I said, we will have then hopefully plenty of time to answer all your questions. We will record this webinar, and of course, we are happy to send the recording once it's finally edited, together with everything that we discussed here, but more on that later. So I think a question that many ask, why multiple models anyway? I think most of you might be aware, if you build your application, and it doesn't matter if you're in a microservice architecture or in a monolithic one, you have different services or modules that serve a client or a user interface, and you need, in most cases, a persistent layer. And these modules and services might need different data models. So some might need a graph, some might just need a key value data model for simple lookups of very simple data. If you want documents and have unstructured data, you might need a document store. And of course, the classic relational model should not be forgotten here. Developed over several years and in many cases a very good solution. And these different data models or using different data models has a lot of advantages. You can natively map your data to the database. You can precisely tailor your queries for a certain use case or to serve a certain feature. And you can leverage data model specific optimizations in the query engine, so your queries run faster and you can build just cleaner application. Whoop. So many ask us, so why isn't a single model enough? So if you want to, if your application needs or could benefit from different data models, and you try it with a single model database, then normally you end up with a scenario where you have to build in stunts and workarounds in the application layer. You can't optimize for other data models other than the one that is supported by a single model database. And you lose the advantage of the native mapping of your data to the database. An open question is for sure if this is then a scalable approach. So with the amount of data that gets generated in today's applications, I think it is rather questionable. The approach that then occurred is polyglot persistence. So use the right tool for the right job. And this, of course, has a lot of advantages. You can, again, leverage the data model specific optimizations. You can have very efficient queries, and you can use the optimizations that multiple single model databases provide. But you end up now, if you want to integrate different database technologies into your application, sorry, then of course you have to learn and orchestrate multiple technologies. You have to evaluate them during your POC phase. You have increased complexity, so handling all the different technologies in one application is for sure not an easy task. An open question is how you want to ensure consistency among different databases if you need this. And what is not possible in most cases is that you can then also run multi-model queries. With multi-model queries, I mean combining different access patterns in a single query. For example, you do a join to then use the results as the starting point for graph traversals. Because single model databases, or let's say MongoDB, Neo4j, Redis, and let's say Postgres, are not meant to talk to each other. So this is the perspective if you want to use different data models, or if you need to use different data models in a single application. If we now zoom out a bit and check out the perspective on an organization level, then we see also different other problems that occur if you have a lot of databases that you have to handle in your whole organization. I found a recent survey from ScaleGrid, who asked several developers how many databases are running in production in their organization. And as you can see, more than 2/3 answered that it is more than one database. It's not surprising, but what is surprising is that even or nearly 30% say it's 5 databases and more. So from our perspective, from what we learned from our customers and users, is that large enterprises easily run 10 to 20 different databases in production today. And this, of course, has different various disadvantages. You have a fragmented technology landscape. The skill set of your development team is rather fragmented, which makes it difficult to assign the different teams to new projects. Of course, a high infrastructure complexity comes with that. You have to upgrade and maintain and run all these databases. And of course, you end up with multiplied costs. Because if you go with an enterprise or some business relationship with all these vendors, you have multiple contracts you have to close, which includes contract costs and evaluation and negotiation costs. So this is a big issue as far as we can see for larger enterprises. So what does ArangoDB do? So what we found a way to is combine 3 different data models in one engine and in one query language. So we, at the very heart, we could be seen as a document-oriented database. If you store just a key and a value, then you have the characteristics of a key-value store. We have to store a bit more information compared to a classic key-value store. So we have a little bit more overhead for this data model. But if you're not in a hyperscale situation, ArangoDB can serve your needs very well. The interesting part now comes in when we form the graph, and we form the graph in a pretty interesting way. For us, edges and vertices, so the elements of a graph, are both full JSON documents, and edges are pointing from one document to the other. We have a so-called from and to attribute, which define the direction of one connection. And these information, so the from and the to attribute are then put into a hash index, which is the edge index, which gives us the possibility to query even complex relationships with a constant time. So these are the 3 data models that we support natively. And what we introduced with 3.4 is also Arango Search, which is a search and ranking engine. So you have in the open source version, which is completely Apache 2, you have a document store, you have a graph store, you have a key value store, and also now a search engine. So one of the advantages of this approach is a huge solution space. So what you see here on the x-axis is the data complexity, ranging from a key value to documents. With JSON documents, you can store arbitrary complex data, and you can even nest properties within one JSON document. On the y-axis, we have the relationship complexity. So key value basically does not really have any big relationships. Relational databases, as the name says, have joins and can thereby express relations between data points. But joins are, compared to graphs, a bit more complex to write. And if you search for a varying depth or an unknown depth, then relational databases and joins are normally not performant and really hard to write. So graph database is specially designed to provide very easy access to complex relationships and analytics of relationships. So with ArangoDB being a document store on the one side and the graph store on the other side, we have the possibility to store very complex data and also query for a variety of relationship complexities. So performance is always a topic, of course. Never trust a vendor's own benchmark. That's why we open sourced it completely so that everyone can see for themselves. So queries, data set for all the different technologies. Our goal with this performance test, which you can find under arangodb.com/performance on our website, was to test ArangoDB against the market-leading databases in their respective data model. And we wanted to test different workloads. We're not always the best solution there. If you can see, beating Postgres on aggregations is rather impossible. But we could show that we can at least compete with single model databases on their home turf. On the right side, we also did a cluster performance test. We wanted to know how many nodes do we need to provide 1 million writes per second. And we got this, what we could show is that we can scale linearly, so the blue line that you can see here, and that we're also competitive with other distributed databases. So where did this whole idea of multimodal get us today? We could save 17.2 million in funding. The latest funding was announced beginning of this year. We could hire 60 very awesome team members. We have a few downloads. We have over 8,000 people supporting and joining us on GitHub. Most appreciated 95 external contributors. Without the contribution from the community, I think we would never be there where we are now. We could also confirm with surveys and talks with our or chats with our community and customers that we now have roundabout a little bit over 500 production installations confirmed. We're open source. There might be more, but 500 we could confirm. And under our belts, we also have Fortune 10 and Fortune 500 customers. A few of the logos you can see below. So at the moment, we don't know how big the problem is that we're solving, but what we can say is that it seems like we are solving a real problem with our multi-model idea. A few use cases you can imagine for a native multi-model database that you can use as a graph database, as a document store, as a combination, however you like. The spectrum of use cases is quite broad, ranging from product recommendation engines over threat intelligence and cybersecurity. We have a lot going on in IoT because many IoT networks fit well to a graph. The metadata that you then store for your sensors fits well to a document model. In manufacturing, we have a lot of fleet management. If you think about an aircraft and the different parts and the different components, this also forms a graph. You have also then different information that you want to store for these parts. So a JSON document comes in handy. So you can see we have quite a large spectrum here. Also some name dropping, and that you can see that it is not just out of the air what I'm telling you today. We have Barclays working on an identity and access management for over 200,000 employees. That's not only their employees, they also have application devices. They also have then several documents they handle. They need a fine-grained access control and decision tree. So they easily have to handle billions of nodes and edges. And therefore they chose ArangoDB. We have also Thomson Reuters, who are building BI applications for business intelligence and business analytics. Our contact there, Tanvir, said that this kind of solution and this kind of application is just not graphs only and is just not joins only. So that he needs a combination of both. And also the JSON flexibility comes in handy. Fox framework is very intensively used. So it's a framework for writing data-centric microservices. If you're familiar with the relational world, you can also have stored procedures with ArangoDB. But also in modern machine learning pipelines and machine learning applications and use cases, ArangoDB can have a benefit. So InnoPlexis has two products. It's Kplexis and iPlexis, and they went fully native multi-model. Before ArangoDB, they had various databases, which of course led to the problems that I described at the beginning. And also had a lot of data redundancy. They also had the challenge to keep data consistent among the databases. So ArangoDB helped them a lot and provided some value. Of course, in addition to the ArangoDB open source version, we also have an enterprise version. We focus there more or less on many security features, so encryption 360, auditing, LDAP integration, multi-data center support. And now with 3.5, we will also release a data masking. The data masking has an enterprise version, but is also in a fundamental version available in the community edition. And we will also offer a managed service quite soon, which will also run the full featured enterprise edition. But if we now switch the focus a bit more to the schema that is on the left side, what you can see there is that different data models of querying for different relationship complexities is not that easy. So if you go into a cluster and data needed for your queries resides on different machines, then you can easily run into the problem of network latency during query processing. So what you want in these cases is a solution to shard the data in a way that the query can be processed locally on each DB server. And our motto is to provide the same flexibility you have on a single instance also on a cluster. So we came up with the idea for smart graph satellite collections, and now with 3.5 smart joins. These are features to minimize the network latency during query processing, and that you get close to the performance of a single instance, even if you have the need to go to a cluster, either because you want to have the high availability characteristics of a cluster, or just because your data set doesn't fit on any machine, on one machine anymore. If you want to learn more about smart graph satellite collections and smart joins, I'm happy to send you a link to the webinar from, I think, 2 or 3 weeks ago, where our head of engineering and our talent acquisition manager, Gudrun, made a webinar especially for these features. So, as I was introducing already, we will launch a managed service. It's a fully managed ArangoDB cloud. You decide which cloud provider of the supported ones you want to go with. You can, I think the first supported ones will be Google, AWS, and then for the GA version, definitely also Azure. Choose your region, your cloud provider, the instances that you want. It's completely self-serving. And usage and the pricing will be will be usage based. The status at the moment is that we are about to enter a closed beta. So with selected customers, we will start a closed beta in around 3 weeks. We are rather confident that we can then go GA end of Q3. Maybe it will be early beginning of Q4. But this year and pretty soon we will have a fully managed service of ArangoDB. So I think enough of my blah blah. I think you all want to see ArangoDB a bit more in action. So I would like to hand over to Chris. And if you have any questions about my part, I'm happy to answer it in the Q&A section below.
Excellent. Alrighty. Thank you, Jan. And I will go ahead and start sharing on my end here. Okay, there we go. And all right, so today kind of what I wanted to do was I'm going to start off with giving everyone a sneak peek of the ArangoDB Oasis, sort of the general layout, what we have to offer there. And then we're actually going to hop into doing some queries. We're going to do kind of quite a few. We're going to do some basic joins, grouping, aggregation, even a geo query, and a graph query. So that's going to be a lot that we'll cover. So what I'm going to do is show some of the like kind of basic examples of those, just to give you some insights on how you can do them. And then we'll provide some resources and things if you want to continue learning more from there. But first, this is the ArangoDB Oasis dashboard. And as you can see, you start out with creating a project, and then you can create deployments within that project and have multiple projects and everything from there. Right now, I'm running on the sort of the trial one. And I guess I should probably say, full disclaimer, of course, that this is the in development build that we're seeing here. So assume that a lot of this will probably change. And so I wanted to show you, so this is the deployment that I set up for the webinar today. I'm using AWS, and as Jan mentioned, it's going to have AWS, Google Cloud, and Azure eventually, I think, with the initial release. And you can choose the region and everything that you create those in. And if we click on View, this gives us kind of a broad overview of the configuration that we have set up. This is, I think, maybe even our smallest deployment, just as sort of testing it out. And you also get an overview of all the agents, servers, and coordinators that are involved in the cluster. So if there's any of them having any health issues, you'll get some indication of that here, and kind of have an idea of where to go from there. Also on this page here, as far as like needing to manage anything, you can create the certificates that are used for the authentication in the server, policy management, members, groups, roles, really kind of anything that you would need to manage your deployment as you go. And it also has a handy endpoint link that will open up our web view. And whenever you set up a deployment, it automatically generates a root password for you. So we're just going to copy that, and so that I can use that when we get signed in. Okay, that was kind of a quick run through. I thought about maybe making a deployment for us today, but it sometimes can take some time, as you can imagine, to get the entire deployment up and running. So rather than spend time on that, let's just go ahead and actually hop into doing some of these queries. And I will show you, we'll connect to the system database first here. To show it brings you to sort of the standard page that if you're familiar at all with the web view, this page gives you a lot of the data that you have going on with your server. As you can see, a little bit of the development build is showing, just as far as not having a lot of data to look at, and also just this being an instance that's not really seen a lot of use. But we can edit everything we want to see. If we had any collections available, which I don't, we'll switch over to the webinar, which does have that one. But this is the full normal web view interface that you get with the Oasis as well. Let's go ahead and switch over. Okay, here we go. Okay, so this is the database we'll be using for the rest of the webinar. And for all the queries, what I'm going to be using is the airports and flights data set. And so I wanted to take a look at some of the airports documents just so that we know what's in them. And so this is just sort of a standard document store. And kind of like Jan mentioned, where we have 3 different data models, you'll see this underscore key value and then the value assigned to it. If you wanted to just have access to just a key value store, these are the attributes. These are some of the system attributes where he's talking about some of the extra overhead that would be assigned. They're automatically generated from the key. But with the key value, it is created with what's called a primary index, which means that you can still do very fast queries just for the key and value associated. With this, we have a lot of other information here. For our airports, we have the name and then basically the location information. So city, state, country, and then latitude, longitude, and then a VIP attribute, which we'll actually use this in one of our queries, I believe. And this is just to indicate if the airports have a VIP lounge or not. So all of the airports have this attribute. Some of them are true, some of them are not. Let's take a look at the flights. Now, the flights collection is an edge collection. And the edge collections are the sort of connecting lines during our graph. So for our use case here, these are literally the flights that go from one airport to another. And if we take a look at one of their documents here, you can see that these flight documents contain all the flight relevant information. So the day and time that they depart. And then there's also this tail number attribute, which is just the specific plane. So a lot of these documents are going to have the same tail number because a lot of the planes have more than one flight that they'll do over a period of time, and as well as the distance of that flight. Now, the sort of different attributes that come along with an edge collection are these underscore from and underscore to attributes. And these are sort of what help the graph traversal happen. So this is like the starting point for the line. So you have the flight that's leaving one airport, and this is the sort of starting airport and then its destination. And we'll take a look at a graph a little bit later as well to get a better idea on sort of what I'm talking about there. But these are sort of the important attributes that help with graph traversals. All right, and I'll try and hopefully I'm going at an okay pace. We're going to, be close on time, so I do want to make sure we get through everything. But I wanted to start out with sort of a basic for loop. In ArangoDB, whenever you're doing a query, it's really common that you're going to use one of these for loops. And basically what this does is it allows us to iterate through either a bunch of documents or normally a full collection of documents. And the basic syntax is that you start out with the for keyword, and then you declare a variable. This could be called anything. I'm calling it airport because we're looking for an airport in the list of, or the collection of airports that we have, but this could be a letter or just any name. It just needs to be a variable. And then the next thing here is, for this, I wanted to just show finding all of the airports in a specific city. So I chose Dallas. And then what that will do with filter, it will look for airports that have a city attribute that is equal to Dallas. And then if it finds that, it will let it go on to the next. You could have multiple filter statements here if you wanted, or other criteria. And then eventually you can return the documents that match all of our criteria. So if we return this, it returns 3 airports. So there's 3 airports in Dallas. I've got Redbird, Downtown, Heliport, and the Dallas Love Airport. And this just returns all of their information. We don't have to return the entire document because this is the actual airport itself. We could just say like return name, and it would just return a list of the airport names. Something additional that we can do as well, because all of our airports do have location information, we can actually show all of these airports on a map. There is a lot of geo functions that ArangoDB offers to treat the data as it kind of generates GeoJSON data and then passes that to on down, so that it is actually treated as full GeoJSON documents. And I'll show you what I'm talking about here, because with the web view here, we have this OpenStreetMap, and this just allows us to display points. So we could actually visualize our 3 airports and their actual locations on a map here. And if we look at the JSON, you can see that it did just generate the coordinates for that, just from the longitude and latitude that were already on those documents. Okay. So that was just sort of a basic overview of the for loop. We're going to pretty much use the for loop, I think, in every query that we have, and it's really common all throughout AQL. And so kind of to move on to what we had talked about before, we were going to look at doing joins with ArangoDB. With ArangoDB, you take the for loop and you can actually nest them. So we've got two for loops here. This first one is that same one we were just looking at, where we've got a city in Dallas. But for this one, what I wanted to find was the flights that are coming to Dallas. So we take all of those airports in Dallas, and then we look for all the flights going to them. This was, for me, kind of a way to think about it would be like if you're looking at a terminal in an airport and you see planes that are landing, and you want to get the idea of maybe where they're landing, the time they're landing, and that sort of information, the flight number. So this is a way that we actually take a look at two collections in one. And so once we actually have the airports, our list of 3 airports, we can move to the flights collection. And we do the same exact thing as we did up here. We can just create a variable. This could have been called anything. And then we supply the collection that we're searching in. So for this first filter statement, what we're saying here is that we're looking for flights that are going to one of these airports, because this is the same airport variable from up here. And this ID is just sort of the unique identifier, like we saw when we were taking a look at the documents. That's what these point to. They point to the ID. So the next thing down is basically we're just looking for flights that are landing at these airports on a specific day. So the second day of the first month. And then as you can see here, we're able to still access the airport variable in our return. And these are going to be only the airports that match all of this criteria. And the same thing with the flight information, because we have the flight number stored in those flight documents as well as their arrival time. So let's take a look at that here. And so you could do all sorts of things here. You could begin sorting it if you wanted to sort by, their estimated time of arrival. If you only wanted to show a certain number, you could limit them. But basically, the main thing I wanted to show is that we're how we handle joins with AQL is basically by nesting these for loops, and you can continue to nest them. It doesn't have to end here. You can, well, there's a lot of ways. So to avoid trying to go into all of that, this is the basic idea behind joins in AQL. Okay, hopefully that was clear for everyone there. I'm gonna have to keep moving on to the next one, but I think we've got Jan possibly watching for questions as well. Okay, so the next thing is I wanted to show for grouping with AQL. So I thought a good task for this would be, we have this data set with all of these airports in it and all of their location information. This task that I kind of gave myself here was, let's find all the states that have airports, and then we also want to see which state has the most airports. And with ArangoDB, that's fairly simple. We're just going to start out with our trusty for loop here, and then we are going to collect them. So collect is the keyword that sort of starts out our grouping stage for us. And we follow that up with needing to declare a variable here. And this is pretty important, because once we get to collect and we declare that variable, any of the previous variables that we had in the scope are lost. So like this airport variable that we've been able to use previously, after this statement, it's not available. We only have access to what we're supplying here. There's a bunch of different syntaxes for collect to try and make as many of these variables available, or as much of the data as you want available. But that's just something to keep in mind, is that once you use collect, it begins grouping. And the reason for that is that if it's grouping all this data as well as keeping all that other data in memory at the same time, that can really start adding up and affecting performance. So just a call out that I wanted to make. Usually if you're doing a grouping like this, probably aren't going to want that, but there's definitely ways that you can still have that. You can declare multiple variables here just by having a comment and adding new ones to Groupon. Okay, so running just that one, actually, just to kind of, I just want to show you that. So if we just ran this, where we just grouped the state, this is just going to return all the states that have airports, basically, because it looks through all of our airports and looks for their state variable, and then just groups them. So it only stores one per state that's actually available. And okay, let's go back. Okay. The next thing in the list here was that we wanted to get the total number of airports per state. And so we have this count keyword. It's actually a clause of the collect statement. And so this statement here is saying with count into, we're saying we want to use this count clause to actually count the number of airports in each state. And then this is just saying we're going to put all of those, put that number into a variable called total. So we have our state and our total variable all in this one statement here. And then here we're just sorting by that total variable. And doing that gives us all of the states with airports and the total number of airports in those states. So as you can see, Arkansas is 263, followed by Texas and California. So that's just basic grouping rundown. This is also used as collect keyword, and this sort of syntax is used in aggregation as well. And that's what I would like to take a look at. We'll take a look at that in a minute, actually. Let's see. But first, just to kind of maybe pause there and make sure we're all on the same page. So what this query is doing, this is kind of showcasing using the nested for loops, using that joining of data. We can still use that with this collect statement. And I wanted to show that even though I mentioned that some of the scope variables aren't available, you can still have access and you can still make use of a lot of the data. So we're back to our filter statement here, where we're filtering for airports that are located in Dallas. And with this query, I kind of gave myself the task of, okay, we're looking at flights from Dallas, and we want to just see what the most popular flight out of Dallas is. So where's everyone going? So like, let's take a look here. So right here, we're saying flight underscore from. So that's the departure. Before we did underscore to, which were flights landing in Dallas. Now we're looking for flights going from Dallas. And we're doing the same thing, which is we're matching the ID here, which is our airport that we get from here. And we want to make sure that the underscore from field in the flight that we're looking at is saying that it's leaving Dallas. And then we're doing another collect. So we're grouping the flights that are leaving. And we want to know where they're going to, though. So sort of just to make sure I'm not talking past that. So we initially get flights that are leaving Dallas. And then we want to say, okay, of those flights, let's start grouping the flights that and figuring out where they're going to. And then we do the same thing with a number of those flights. So I think this will make a bit more sense once we run it as well. So, okay, so basically what we're seeing with these results is that of the flights that leave Dallas, the number one destination of those flights are to Houston, probably sort of like a layover or something like that. But so of all the flights that leave Dallas, 378 of them go to Houston, and that's followed by Austin, and then San Antonio, and then this is Kansas City, actually, Kansas City, Missouri. So we get out of Texas eventually to go to Kansas City. Okay, so that just sort of showcases the ability to have nested for loops to join our multiple collections together, and we can sort of solve some real questions that you might have when wanting to look at your data to try and figure out, okay, we have flights a bunch of flights leaving Dallas. Where's everyone going? Maybe we can get an idea on maybe we need to have more flights to those cities, that sort of thing. Okay. And okay, so the next thing I did want to talk about is aggregation. So with aggregation in ArangoDB, you kind of following on this grouping mechanic of getting these results, grouping them together, and then being able to perform some function to make some sense of them. Without our specific aggregation keyword and that sort of workflow, you can still accomplish these sort of things. So the task that I gave myself to show this was, okay, let's try and find, of all the flights that we have in this data set, let's try and find the shortest flight and the longest flight. And so that requires taking a look at every single flight and tracking its distance attribute that it has. And so what we're doing here is just a normal for loop where it looks in our flights collection, and then it just returns the distance attribute. And this here, what this is saying is take all of those values and put them into this A variable. And what that does is it provides us with an array, because with the min and max functions here, it evaluates an array. So that's why this is necessary, because it gets all of our distances in an array. And then we can return those. So we get a min, and we get our shortest flight, and max being our longest or the biggest number in that array. We can go ahead and execute that. And so here's the results we get. The big thing I wanted to point out with this is that what happens here is we have to get every single distance into an array first. And then that array has to hang out in memory as we pass it through this function. And we can only pass it to this function once we're done here. And so what we'll see in just a moment is the amount of time it takes for that, but then also it's important to keep in mind if you have a really large data set where you've got to hold a lot of these values in memory, that can start adding up pretty quickly. And so if we switch over to how we can do it with the actual aggregation value, we still have our for flight in flights. So we're still looking in the flights collection. We're using that same collect keyword, but it has another clause called aggregate. And what this does is the keywords that follow this aggregate clause have a special variation on how they work. So the min value, rather than taking in a full list of items in an array, it assigns one item to this min distance variable that we created here. And so what this is doing is saying, okay, the smallest value that I have found so far is this number. And as it looks through all the flights, it goes, okay, this number is now the smallest number. And it just replaces that one number. And it's doing this at the same time that it's looking up these documents. So we don't have to wait to get all these results and then pass it to a function. It's just doing it as it goes. So that's really where the big performance gain comes in, is that it's not a two-part process anymore. And then the next thing is, of course, just the sheer resource availability. Now that we're not holding this whole array result set in memory, we just have two items that we're doing that with. So if we execute that, you can see just performance-wise, we go from 400 milliseconds to 158 to get the exact same results with a lot more benefit. So just something to consider. If you're interested in aggregation, that's a huge, of course, performance improvement. And there's a couple different functions that we have special aggregate versions for. But I think this was hopefully an understandable way to show that off. Okay, well, I think we're making pretty good time, actually. I might be flying through, I don't know. But the last one I wanted to show is the graph. So just sort of to where we're at now, we've looked at basically the key value process, which would be just sort of filtering on the underscore key, and then our sort of a more standard document store and how we would query that. And all of that has been with the same data. And just like with this query I'm about to show, it is a graph query We're still using the exact same collections. It's the same data set. It just depends on how we decide we want to query it. And it's that sort of flexibility that because I guess I'm hoping to convey is useful out of a multi-model. Because we get to work in the same database with the same data set, but we get access to multiple data models. And so we're using the for loop here for our graph, but it comes with 3 variables. So normally with the for loop up till now, it's just, you just declare one variable here, and that's the variable you're going to use throughout trying to define more information on it. But with graphs, we iterate over airports, and then that's our vertex. So again, these can be whatever you want. They don't have to be these letters. They can be whatever you think makes the most sense. But for me, it's going to be V for vertex, E for edge, and P for path. And I wanted to just really quick give you a look at sort of what that looks like. So for this query, what I'm actually going to do is try and find a flight from San Francisco, which is SFO, to Hawaii. And we're gonna, I'll talk about the depth in just a moment. So with the graph traversal 4 variant, basically what it's saying is our vertexes are going to be the airports, so these sort of nodes here, and our edges, the lines that are connecting these nodes, are the flights. So whenever we talk about an edge, we're talking about a flight in our use case. And then the path would actually contain, so our starting place, which is San Francisco for this one, the flight, and then the destination, which I don't actually know what MOD is. But so it's going to have the starting airport, any of the number of flights, and then any number of vertices that it takes to get there. And having that access to the path is often useful, and you'll see that we actually use it in our query. And by the way, that view is just a sort of quick graph view. It allows you to get a really quick kind of random snapshot at some of your data. I don't want to go too much into that because there's a lot of options there that you can do to try and help just visualize the graph, but that's basically what that is. And so those are our variables, and we're saying in, and then we supply the depth. So basically, how many flights do we want our trip to be? Since we're flying out of San Francisco, I chose 2.3. So that's saying a minimum of 2 flights or 2 edges, and a maximum of 3 flights or 3 edges. And so no direct flights, basically, is what that's saying as well. So no one connection. And then the next thing is the direction. So this is just to clarify that we want to be leaving San Francisco. We're going outbound. We're using that underscore from attribute to say we're going from San Francisco. Next, this is graph. So this graph keyword specifies the list of vertices and collections. So whenever I click on graph here, I've actually defined it already. We can take a look at what's in there really quick. And this is going to be flights and airports. So our edges, of course, the flights, and we already know the from and to collections are the airports. That's just sort of a quick idea of what I'm talking about there. Instead, if you didn't have something like that declared, you could just list the edge collections that you wanted to use instead. That's called an anonymous graph, and there are some ups and downsides to using either there. And the next one is options. All this is really doing right here, it says unique vertices and path. We just want to make sure that along our path, we're not coming back to San Francisco, basically. So we want to make sure all the airports are unique so that we're not leaving and having to deal with all of that. And the next thing here is actually our destination. Let's get a little space to make that easier to read. So this filter statement is saying we're looking for airports or our vertices that have an ID of KOA, which is Kona International Airport, and that's in Hawaii. And so that's sort of us setting our destination. The next part here with these two is saying we want these flights to all be on the same day of the same month. We want to make sure that we don't get off at one airport and have to wait a week to get on the next flight out. And this is looking on our path. So we say of the edges, so of the flights on our flight plan that so far have passed all of our checks here, we want to make sure that they're all here the same day and on the same month. And the last two here are checking the landing times, basically. We want to make sure that we land and have enough time to get to our next flight before it leaves, and that we're also landing before it's left, is basically what that's doing. So if we have multiple flights, we need to check each flight there. There's a lot of date-specific keywords. That's what we're doing here, is adding time to the date, to the time that we land. Sort of going to avoid going into that just to keep us going on time. And then I'm just limiting the number of results. As you can imagine, as you traverse a graph, there can be options for a ton of different ways, and especially with our airports collection where it has a lot of flights that are leaving, us getting just the 10 first available flights is going to be good enough for us here. And then I'm just returning the path because that has everything we need for all of our flights. Okay, and so doing that, you can see that we get this nice little visualization of potentially what a flight could look like. So here's our SFO, so San Francisco Airport. Looks like we pretty much, in the first 10 anyways, go to Denver, and then we either go to Phoenix, LAX, or that one, which I don't know, HNL. I guess we could actually look. If you click on this JSON, it'll always give you the JSON readout, or you can go back to the graph readout. But because we returned that path, we do get to see all of the edges that we're going down. So here's our different flights. We get the flight number that we're taking for each one. And, well, I won't look for it. But that's just gives you access to be able to find that information out quickly. And so with our graph traversal, you can see we still are using the basic principles that we used in all the other queries. You just make some adjustments in how you're looking at that data. And now you have just full graph functionality. Okay, I think I probably ran through that. So hopefully we still have good time for questions and that sort of stuff. If you guys have any questions, we of course have a lot of resources for learning more about this stuff as well. We have a great graph course for freshers that really takes you from very beginner on the graph course to more advanced ones as well. So if you're feeling not quite sure about some of this, we definitely have a lot more resources. And of course, there's a lot to learn about graph traversals as well. But for the most part, it's kind of this easy. And then something else to keep an eye out for would be the Udemy course that we have coming up. I walk through the very, very simplest of queries, and we go a little bit more advanced to try and give you a full overview on how a lot of this stuff works. But yeah, I think that was everything sort of that I wanted to show off. I'll pass it back to Jan.
Perfect. Thank you so much. Really, really cool. We had a few questions in the community, in the chat. A few I already answered, but I just wanted to share this also with you and everybody. Just real quick, I got asked if Arango Search is on the same level as Elasticsearch. And of course, that's a great question and totally valid. And our answer is that we don't compare ourselves to Arango Search, to Elasticsearch at the moment. So Elasticsearch is written in Java, we're written in C++, but this is not the differentiator. Arango Search was just released, I think, six months ago. So this is the first release. We're now adding more and more features. But for us, it's more the multi-model aspect of having the possibility to combine native graph or document search with queries with search capabilities and ranking capabilities. And of course, we add more and more features, but we would not compare ourselves, and we don't compete with Elasticsearch there. Another question was that if the indexing affects AQL and query performance. So of course, an index, if it is used in a query, has a high impact and a high positively impact potentially on a query performance, as Christopher or Chris showed in this part. For the write performance, yes, it has, of course, additional writes have to be made. But the impact, depending on the index, is really minor. But if you get very complex or have a lot of indexes, then you might see 5 to 10, maybe 15% of decrease. But as I said, this depends on the nature of the index. But we have indexes in ArangoDB for forever, basically, and also optimized there a bit. Then the question was if we support .NET officially or if there are any plans. At the moment, we don't have any professional level .NET skills at ArangoDB ourselves. It is a community driver, and we would highly appreciate any contributions, of course. And we're also looking always for cooperations with driver developers for languages that we don't support from ArangoDB directly. Last quick question was if ArangoDB is fully UTF-8 encoded, and the quick answer is yes, we are fully UTF-8 encoded. All right. There are just a few others open. Chris, would you like to take over and answer a few of them if you like?
Sure. I'll just see. The next one I have is what is the limit to the number of nodes on a cluster, and will that limit stay the same for the foreseeable future?
Directly the hard one, right?
Yeah, I'm like, do you know the answer to that one actually?
There is basically not a set limit for machines in a cluster. What we showed in our performance test is that we can scale to 100 machines. And ArangoDB, we feel comfortable ArangoDB running in clusters, let's say 10 to 30 machines. Then if your queries run then in the expected performance, this depends then on your data model, on your queries. And if you have such a use case, always feel free to ping us and ask us for our opinion. You can directly contact me if you like. It's just my name at arangodb.com, or join me on Slack or wherever you prefer.
Excellent. And the next one was, I guess, maybe more regarding potential cost. Are you seeing that there with the question from Joseph?
Yeah, so the question is they used Neo4j and ran, as it seems, in the licensing problem. ArangoDB is full Apache 2, and ArangoDB also supports Graph in a cluster in the community edition already. If you want to test it and the performance is not right for you, then you can check out the Enterprise Edition and Smart Graphs. I can't comment on the licensing costs of Neo4j, but from my feeling is that ArangoDB is more than compatible. Difference is that our pricing model for the licenses is on a server base. And as far as I know, the Neo4j pricing is on a per core base. As we have the document model at our heart and our scalable and distributed database from the get-go, we also have a pricing model that accommodates rather larger data sets. So ArangoDB is also C++ based. Neo4j is written in Java. I'm not 100% sure if the heap map, the heap JVM heap problem exists for Neo4j. That's something I don't know. But ArangoDB is written in C++, so there is no limitation also for the amount of data that you process on a single instance. Of course, the single instance should be capable of holding the data, but ArangoDB doesn't pose any limitations there.
And the next one is asking about tools for query debugging and performance. And I think if we've got like okay time, I could quickly show that. But or just maybe to answer, we definitely do have that. So all right, I will just quickly show you in a really quick. So in the web view here, of course, you have access to this other places as well. But we have the ability to either do the explain, which is take a look at what our sort of fancy schmancy query optimizer will do before it runs the query, or we could take a look at the profile, which actually runs the query and then gives us an idea of what actually happened. And so it goes through the full execution plan, and then talking about some of the indexes, it actually shows the indexes that were used. And so these are some indexes that were created on the collections. And as you can see, it's going to use an index per collection. So because this is the join query that we did, it's actually using one per collection. And yeah, there's a lot more information on that, but yeah, we do have those features available. And yes, we are going to have a download for the recorded session. And after this, with that, we'll be including the queries that I ran today, so you can try them out on your own, and the data set that you can download and do all of these queries yourself as well. So, yeah.
Yeah. So another question is if we provide encryption at rest. Yes, ArangoDB Enterprise supports encryption at rest. And also the managed service will have very high security standards, encryption 360, so everything is encrypted before it hits the disk. So also encryption at rest, encryption on transit. So everything that the Enterprise Edition has will also be part of the managed service.
Excellent. Okay. Well, that is all the questions that I'm seeing there.
Yeah. There's also something in the chat. Is there a question? Kevin, if you're still there and hearing me, I will get back to you on the tutorials, and yeah, send it with the whole package that Chris and I will prepare for everybody who joined us today.
And kind of to tie into that as well, he's talking about certain tutorials and things. You know, we do have a lot of learning resources available just at arangodb.com, either through our docs or through the learning portal that we have there. But definitely would love to hear if we're missing any tutorials or anything that you guys would like to see. That's sort of what I'm doing. So I would definitely be interested to know if there are learning resources that anyone either watching or not watching would like to have. And I want to make sure that we're able to provide the best learning possible there. So please let us know any feedback you have there. Perfect.
Yeah, and if you have any questions later on, we're already 10 minutes over the set time, so sorry that it took us a bit longer, but we really enjoy the many questions that you have. If you have any feedback to us, Chris and I would be really happy if you could provide that. We're both new to this whole webinar thing, so it would be great to also get your feedback if you like the webinar, if something was missing for you. So we can both improve. So then closing up, just want to say if you like what we're doing here at ArangoDB, then also find our code on GitHub. We are working and coding and sometimes face palming together with our community on GitHub. Would be great if you join our stargazers. And bookmark ArangoDB the repo. Other than that, you will find Chris and me also in our community. And if you have any questions, just let us know. Yeah, I would say from my side, thank you so much, Chris.
Thank you, everyone.
Yeah. Then I would say bye-bye. Thanks, guys.